program also has the ability to offer some well-designed solutions as well for certain types of connections. Starting with the one-branch connection, if we use rectangular hollow sections, we can do a fillet weld design when a fillet weld is possible. So if we enter some loads, we enter an electrode strength, and we try and do a branch angle. Let's make that a T connection. And we want to do a weld design. We're going to get an error here saying that fillet weld is impossible because the branch does not fit on the cord flat. So let's go ahead and pick a smaller branch that might work for this application. That should do it. Now we get brought to this weld design calculation sheet. Here it tells us how the weld design was performed. It tells us all the member input, all the member properties, the loads acting on the branch, and then the effective weld throat which the program has chosen. And it does this by iterating and increasing up the weld effective throat by 0.1 millimeters each time. It does 0.1 millimeters so that when you convert to weld leg size, you have the resolution necessary to not lose a lot of, waste a lot of material based off some rounding errors. And this is an effective throat around the branch. It is not the weld leg size. And for a T connection, converting is pretty easy. But if you were using a connection where the branch is on the angle, you would have to convert this effective weld throat into a fillet weld leg size all around the branch based off the preference of how you wanted to weld this connection. Down here are the calculations for this weld design. It has the effective width, the effective weld properties for the branch under tension in plane moment and out of plane moment, and the associated capacities. And at the bottom, you can see the total utilization ratio, which is very close to 1, because the program will iterate until it finds the solution, the most efficient solution. Finally, the weld design is also available for 2-branch connections, as well as using US customary units. So if we go to our 2-branch example here, you can see that it is in US customary units, and you can see that the rectangular branches will fit on the cord so that we can fillet weld them. So if we enter our electrode strength, which we'll do as 70 KSI, we can do the weld design. And this weld design would work for 2-branch connections that are X connections, Y connections, or gap K connections. It does not work for overlap K connections, as you can't do a fillet weld all the way through, all the way around. So you can see here that we get an effective throat for the 2 branches. This effective throat, because it's an imperial, is given in a resolution of in 32nds of inches. So that's normally a weld would be specified to the nearest 16th inch, but again, because we're using the effective throat, which would be going all the way around, and the weld would usually be specified as a leg size, this gives the designer a bit more flexibility when converting between the fillet weld size that needs to go around the whole branch. You'll also notice that for the larger branch load, there is a larger weld. Typically in K connections, you will use one weld size all the way around both branches to avoid any errors, but again, all the information is given here so you can make those judgment calls on your own. As before, we have all the equations written out symbolically and numerically for both the weld capacity as well as the effective weld lengths for the K connection, and you can see our utilization ratios. You'll notice that the utilization ratio for the second branch isn't 1. That's because the load in the branch is low enough that the minimum weld size controls this design.